Okay, I need you to hear what just happened in space this week. We may have found the molecules that start life, not here, but in another galaxy. The sun's throwing charged particles straight at Earth again. Astronomers think they found a magnetic tunnel, an invisible corridor connecting our solar system to nearby stars. A visitor from another star system is making a flyby no one alive will see again. Something massive and completely unseen is bending light across billions of light years. And out in the dark, two black holes just slammed together hard enough to shake space-time itself. This isn't sci-fi, it's the last 7 days. This is AstroNews Weekly, and we're gonna break down what the universe has been up to.
So let's start with the headline that quietly blew everyone's mind this week.
The James Webb Space Telescope just found the building blocks of life, frozen in ice, in another galaxy. Webb was looking at a young star system inside the Large Magellanic Cloud, about 160,000 light-years away. In that icy cloud, scientists detected the chemical fingerprints of molecules like methanol, ethanol, acetic acid, and a few other complex organics. All the stuff that, on Earth, eventually links up to make amino acids and sugars. Why that matters is huge. The Magellanic Cloud is what astronomers call metal poor. It doesn't have many of the heavy elements our own galaxy does. For decades, we assumed places like that were too primitive to cook up complicated carbon chemistry. But Webb's data says otherwise. Even in these rough, radiation-soaked environments, nature's still out there experimenting, assembling the same ingredients that could start life anywhere. What Webb's showing us isn't just pretty pictures. It's evidence that the recipe for life might not be rare at all, just waiting for the right conditions. And maybe the most exciting part? This is the first time we've confirmed such chemistry beyond the Milky Way. A reminder that when Webb stares into deep space, it's also looking straight into our own origins. While Webb was busy peering into another galaxy, something much closer to home started making noise again: our sun. Late this week, space weather observatories picked up a massive coronal hole opening up on the sun's surface. A dark region where magnetic fields peel open, releasing high-speed streams of charged particles. These streams, known as the solar wind, are now racing toward Earth at over 700 kilometers per second. When they hit our planet's magnetic field, they do something beautiful and a little chaotic. The incoming particles slam into the upper atmosphere, energizing oxygen and nitrogen atoms, which then glow as auroras. Those ribbons of green, purple, and red light that sweep across polar skies. The current wave is strong enough that the northern lights could stretch unusually far south this time, possibly visible across northern Europe, Canada, and the upper United States. Even a few lucky stargazers in Japan and Central Asia might get a glimpse. For most of us, it's a show. But for satellites, GPS systems, and power grids, these storms are stress tests. A spike in solar activity can throw off communications, navigation, or even temporarily overload transformers. Agencies like NOAA and NASA have been on alert, adjusting satellite orbits and shielding instruments, just in case. What's interesting is that these events are becoming more frequent as the sun heads toward the peak of its 11-year activity cycle, expected in 2026. Each surge gives scientists more data about how solar wind interacts with our magnetic field, a relationship that quite literally shapes the boundary between Earth and space. So, if you live in the right part of the world, keep your camera ready. The sky could put on one of those rare light shows that remind us, even across 150 million kilometers, the sun still runs the weather of our cosmic neighborhood. Every now and then, a study comes along that completely changes how we picture the space around us. A team of astronomers studying the magnetic fields that weave through our local region of the Milky Way has discovered what they describe as a tunnel-like structure, a massive magnetic corridor that appears to link our solar system to nearby star systems. They found it while analyzing radio wave and polarization data from across the sky, essentially mapping how charged particles and cosmic dust interact with magnetic fields. When they combined that data, something unexpected showed up. two enormous filaments of charged material, curving and connecting like the walls of an invisible highway. According to their models, this tunnel could span hundreds of light years, wrapping around the edges of the local bubble. That's the cavity of hot gas and plasma our solar system sits inside. The structure seems to connect us to regions like the Perseus and Taurus molecular clouds, both rich in young stars. What's fascinating is how this might explain the strange ways that cosmic rays, high-energy particles from a distant supernova, reach us. Instead of wandering randomly through space, they could be following these magnetic pathways, guided along invisible rails that link star-forming regions together. If the team is right, it means our corner of the galaxy isn't an isolated bubble floating in the void. It's part of a connected web, a vast magnetic ecosystem linking stars, clouds, and planetary systems over unimaginable distances. The researchers now want to refine their models using data from ESA's Gaia mission and NASA's Parker Solar Probe, which can sense changes in local magnetic fields more precisely. And if these tunnels truly exist, it opens up a deeper idea that the universe may be threaded together, not just by gravity, but by magnetic bridges that quietly shape how matter, energy, and maybe even life itself move between the stars.
And just as we're learning that our solar system may be connected to the stars by invisible magnetic corridors, an actual visitor from another star system is flying right through our neighborhood. It's called 3I Atlas, and it's only the third confirmed interstellar object ever discovered, after Oumuamua in 2017 and Comet Borisov in 2019. This week it made its closest approach to the Sun. It's perihelion, and telescopes around the world captured something truly strange. The comet began venting jets of blue vapor, releasing water, metals, and volatile compounds long before it should have been warm enough to do that. Normally, comets start to sublimate only when they're relatively close to the Sun, as heat turns their frozen ices into gas. But 3I Atlas started outgassing while it was still far away, in temperatures where ordinary comets remain silent. That behavior hints that it was formed under a completely different chemistry, in a different star system, with its own unique conditions. Its orbit is hyperbolic, meaning it's just passing through, not bound by our Sun's gravity, and once it leaves, it'll never return. Right now, spacecraft near Mars and Jupiter are already adjusting to get brief looks at its tail, hoping to capture dust that might reveal what kind of world it once came from. For astronomers, these moments are gold. Every interstellar visitor carries the history of a distant planetary system, material forged around another star, traveling for millions of years before briefly crossing paths with us. And for the rest of us, it's a humbling reminder. Somewhere out there, around another sun, a world was born, shattered, and sent one of its fragments drifting our way, a message in motion from another corner of the galaxy. From something we can see to something we can't, astronomers have just detected what may be the smallest dark matter clump ever observed, hiding inside a warped halo of light 10 billion light-years away. The discovery came from a detailed study of a spectacular Einstein ring, a perfect circle of light created when a distant galaxy's glow is bent by the gravity of another galaxy directly in front of it. While analyzing high-resolution data from ALMA and Hubble, researchers noticed a small distortion in that ring, something that didn't belong to any visible object. The only explanation was an unseen mass, roughly 1 million times the mass of our Sun. That may sound enormous, but in cosmic terms, it's tiny, far smaller than an average galaxy, and it's precisely what dark matter theory predicts: countless invisible subhalos scattered through the cosmos, shaping the way light travels without ever emitting any of their own. The find gives scientists a rare, direct measurement of dark matter's texture, proof that it clumps and ripples rather than forming a smooth background. It's a quiet confirmation that the universe's skeleton, the structure that holds galaxies together, is far more intricate than we can see. The team now plans to look for similar distortions in other gravitational lenses. Each new detection helps tighten the models of how dark matter behaves,
And maybe, someday, it'll lead us to the particles themselves. For now, this faint twist of light reminds us that most of the universe doesn't shine. It just leaves its fingerprint on the white that passes through.
We're ending this week on a discovery that literally shook the fabric of spacetime. The LIGO-Virgo-CAGRA collaboration, Earth's global network of gravitational wave detectors, has recorded 2 separate black hole collisions, and both are challenging what physicists thought they knew about how these cosmic monsters form. The first event involves something rare, a second-generation black hole. A black hole born from the merger of 2 others. That means one of the objects that collided was itself already a product of an earlier cosmic smash-up. It's like watching galaxies evolve, but on the level of collapsed stars. The second event showed unusually high spins and mass ratios that don't line up with standard stellar evolution models. Together, these signals suggest that some black holes might be merging repeatedly inside dense stellar clusters, growing bigger, faster, and stranger than expected. For researchers, these are golden moments. Gravitational waves give us a way to listen to gravity itself, letting us test Einstein's general relativity under conditions no laboratory can recreate. And so far, Einstein's equations are still holding up, but these new detections are pushing them right to the edge. Each of these collisions lasted only a few tenths of a second, but in that instant, they released more energy than all the stars in the observable universe combined. And that's the poetic part. From total darkness, a flash of gravity ripples across the cosmos, reaches our instruments on Earth, and tells us that even in the quiet, cold corners of the universe, something extraordinary is still happening. So that's where we are this week. A universe that keeps surprising us. From molecules that could start life showing up in another galaxy, to magnetic tunnels linking our solar system to the stars, to black holes rewriting the laws of physics. Every discovery feels like another piece of a much bigger story, one that's still being written in light, gravity, and time itself. What's happening out there isn't distant, it's connected to us. The same forces shaping galaxies are shaping the atoms in your body. This is AstroNews Weekly. Thanks for watching. Stay curious, stay cosmic, and I'll see you next week.